You should also be able to find the perimeter and the area of some simple shapes like triangles, squares, and rectangles. Some shapes you already know formulas for how to compute these things, or at minimum know what to do it. Recall the perimeter of something is the distance all the way around it, so it's just adding up all the side lengths. And the area is kind of a measure of how much space the figure takes up on a plane. I'm going to write down the formulas for these that you may or may already not know what they are. But these are formulas that I expect that you know and can recall and use when necessary. Note that for perimeter of a triangle, we generally don't actually write the formula for the perimeter of a triangle because it's just add all the side lengths. But I'm just going to write that. In fact, because in practice, the sides don't need to be the same length. It don't need to be really related in any particular manner. However, the area is a little more formal. We say the area formula is 1/2 its base times its height, where the height is the distance from one of the sides to the opposite vertex, so the opposite corner, at a right angle. So often, for at least early on in this class, we're gonna the heights or the altitudes will be drawn in, and we're gonna use that to calculate the area of these triangles. For a square and a rectangle, they're hopefully a little bit more familiar. We'll write down the areas because I think those are a little simpler, to be honest. The area of a rectangle is just its length times its width. And the area of a square is also its length times its width, but since a square has all sides of the same length, it's like side times side, or it's side length squared. Using that same idea, what's the perimeter of each of these things? Well, the perimeter, there's two widths and two lengths, so if I add them, length plus width times width, that's 2 lengths plus 2 widths. And for a square, all 4 of these sides are the same length. There's 4 of them, and they're all the same length. So I'll say 4s. Again, having the formulas themselves memorized is not the important part, but knowing how to actually compute these things is more what I'm after. So if I gave you the coordinates of some points, we should be able to draw a figure that's representing, and then say find its perimeter and area, like in this case this triangle. So triangle DEC, D is at 1, 3. E is at 3, negative 3. 1, 2, 3, 1, 2, 3. And F is at negative 2, negative 3. Negative 2, negative 3. I think we need to find both the perimeter and the area. Area, I think, it's a little bit more straightforward. I need to find the area. It's its base times its height. The base can be any side, and then we'll calculate the height off of that by finding the distance from that vertex to the opposite side. I think there are 3 possible ways you could do this. One of them is very clearly easier than the other 2. For instance, if you said that DE was the base, then we'd have to somehow calculate the length from F to this side at a right angle, and that looks perilously difficult. Same with DF. I could call DF the base, and I could calculate its length, but then I'd have to figure out what's the distance from E to this side at a right angle, and that also is at a diagonal that's difficult to calculate. However, the obvious and easiest way to do this is using FE as the base, because I can count its length, because it's a horizontal line along the grid lines. So not only is this length easy to calculate, but then the distance from D to this point is also easy to calculate because it's a vertical line along this grid line. So put those 2 things together, and I think it's to find the base and the height is, I think, the smartest way to go about this is to use these 2 things as the base and the height. So I think the base in this case is 1, 2, 3, 4, 5. And the height happens to be 1, 2, 3, 4, 5, 6. Half times 5 times 6. 5 times 6 is 30. Half of 30 is 15. And area is measured in square units. What's the perimeter of this figure? Well, the perimeter is the distance all the way around. And we've already calculated one of them. That's this base. That's 5. The problem is I need to know what the length of FD and DE are. And that's maybe not exactly obvious what they are. We definitely can't count it because they're along diagonals. However, we can calculate the lengths of segments because we know the distance formula. So you could either break this into, maybe draw right triangles and use the Pythagorean theorem to find the length here, or we can just straight use the distance formula from our previous lesson. And I think I'm just, for practice sake, I'm going to use the distance formula. So recall the length of DE, squared, DE squared, is the difference of the x's. So for D and E, how about the x's subtracted, 3 minus 1 squared, and add that with the difference of the y's, so minus 3 minus 3, subtract 3, and squared. 2 squared plus negative 3 minus 3 is minus 6 squared, which is 4. Negative 6 times negative 6 is 36, which is 40. So DE squared is 40, so DE is the square root of 40. So this length is square root 40. Do the same thing with DF. We know the length of DF squared, according to the Pythagorean theorem, is the difference of the x's added with the difference of the y's, and squared each of those. So DF, I'm going to subtract the x's. D and F, how about minus 2 minus 1 squared? The difference of the y's, how about minus 3 take away 3 squared? That's negative 3 squared plus negative 6 squared. Negative 3 times negative 3 is positive 9. Negative 6 times negative 6 is 36. 9 plus 36 is 45. So DF squared is 45. So DF is the square root of 45. Put that together, and I think the perimeter of this triangle is whatever 5 plus the square root of 40 plus the square root of 45 is. This is some weird decimal. I don't exactly know what it is. Maybe I get an approximation of what this is with my graphing calculator. So I'm going to calculate about 5 plus square root of 40 plus, I don't want it underneath, plus square root of 45, which is about 18.033. Lastly, we're building a shed in the backyard. Here's a picture of what the shed looks like. And then looks like in a blueprint, we've got the base of the shed here. And we want to find the perimeter and area of the floor of the shed. So here's a blueprint of the floor. To find the perimeter of the area of this rectangle, I just need to know the side lengths, which means that I should be able to count here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 5. So the perimeter should be 6 plus 6 plus 5 plus 5. 6 plus 6 is 12. 5 plus 5 is 10. 12 plus 10 is 22 feet. And the area is length times width, which is 30 square feet.